Hello everyone, today we will learn about quadratic functions. A quadratic function is one of the form f of x equal to ax squared plus bx plus c, where a, b, and c are numbers with a not equal to 0. The graph of a quadratic function is a curve called a parabola. Parabolas may open upward or downward and vary in width or steepness, but they all have the same basic U-shape. One important feature of the graph is that it has an extreme point called the vertex. If the parabola opens up, the vertex represents the lowest point on the graph or the minimum value of the quadratic functions. If the parabola opens down, the vertex represents the highest point on the graph or the maximum value. In either case, the vertex is a turning point on the graph. The graph is also symmetric with a vertical line drawn through the vertex called the axis of symmetry.
The standard form of quadratic function is f(x) equal a times x minus h squared plus k, where hk is the vertex. If a more than 0, the curve opens upwards. If a less than 0, the curve opens downwards. The highest or lowest point in a parabola is called the vertex of the parabola. The general form of a quadratic is f(x) equal ax squared plus bx plus c. To find the vertex using this form, you need the axis of symmetry, x equal to negative b over 2a. Now, let's learn how to graphing a quadratic function. First, you need to identify which way the parabola will open. Second, identify the vertex. Third, find the y-intercept by evaluating f0. Fourth, find the x-intercept. Then, graph the quadratic function. Now, let's learn how to convert quadratic function from general to standard form. Firstly, start the original quadratic in general form. Then, move the constant value to the other side of the equation and add b over 2 squared to both sides of the equation, then factor the right-hand terminal. And lastly, isolate the y and you are done.
Okay, let's look at this example. Sketch the graph of y equal to x power of 2 per 2. Starting with the graph of y equal to x2, we shrink by a factor of 1/2. This means that for each point on the graph of y equal to x2, we draw a new point that is 1/2 of the way from the x-axis to that point.
Quadratic function in real life. The graph of the quadratic function form a U-shape called parabola. Parabola are quite common in real life situations. Many real life problems can be solved using quadratic function. One type of problem involves objects subject to gravity. They pass a parabola because what goes up must come down. Objects that are launched, such as a rocket, missile, objects that are thrown like a basketball, objects that are kicked like football, they all follow parabola motion. In many of these situations, you will want to know the highest or lowest point of the parabola, which is known as the vertex. For example, consider that when you throw a football, the path it takes through the air is a parabola. Natural question to ask are, when does the football reach its maximum height? How high does the football get? If you know the equation for the function that model the situation, you can find the vertex. If the function is f(x) equal ax2 plus bx plus c, the dx coordinate of the vertex will be minus b divided 2a. The y coordinate of the vertex can be found by substituting the x coordinate into the function. In the case of the football, the x coordinate of the vertex will give you the time when the football is at its maximum height. the y-coordinate will give you the maximum height. One way to understand where minus b divided 2a comes from is to consider where the vertex on a parabola.
Let's do some exercise. Write y equal to x at x plus 12 plus 5 in standard form. Step 1. Step 2. Step 3, and you are done. Let's do another exercise. Graph y equal to negative 2x minus 2 square plus 1. The function is in vertex form y equal to ax minus h square plus k, where a equal to negative 2, h equal to 2, and k equal to 1. Because a less than 0, the parabola opens down. First, draw the axis of symmetry, x equal to 2. Second, plot the vertex at the point 2, 1. Third, plot the points. The x values 3 and 4 are to the right of the axis symmetry. One point on the parabola is 3, negative 1. Another point on the parabola is 4, negative 7. Plot the point 3, negative 1 and 4, negative 7. Then plot their mirror image across the axis of symmetry. Lastly, draw a parabola through the points.
We are surrounded by lots of parabolas. We usually never notice them because we do not really watch them truly. It was a fun experience to practice using quadratic equation with objects that we are familiar with and relate them to our own life. I think it was very beneficial in order to fully understand the concept. Graph of quadratic function have a unique symmetrical with a maximum or minimum function value corresponding to the vertex. When the leading coefficients of the quadratic expression representing the function is negative, the graph opens down, and when positive, it opens up.
Hope you understand and enjoy the video. Thank you.